Hey everybody, Mr. Sharkey back with another exciting chemistry video. Today we're gonna be looking at our data from the mass versus volume lab and hopefully draw some conclusions from it and figure out exactly why we did that lab and why it's important. So what I've sketched here is just a quick example of what your graph might look like by the time you finish up this lab. You should have two lines, one for metal A and one for metal B. I just kind of threw some lines on there. Your data is obviously going to look a little bit different. Line B might be steeper than A, for instance. But generally, two lines, that's what we're going to focus on for right now. In my little graph, I have actually left off a pretty important factor, and that is the axes, both the X and Y. I've left those off. In this example, and if you followed along with Mrs. Katz's graphing video, what you should end up with is you should actually see that we have volume down here on our x-axis, which for the most part was measured in milliliters. Some people had to end up using centimeters cubed, but remember, centimeters cubed and milliliters are equivalent to each other. So as long as you measured in centimeters when you were using a ruler, your data shouldn't be thrown off. But if you have a super wonky data point, it might be because you measured in inches and then got inches cubed instead of centimeters cubed. Sorry, the bell's probably going to go off at another point in this video, but we'll just deal. On our y-axis, that's where we have our mass, which in this case was measured in grams. And the reason that these axes are important is because our whole goal here was to find the slope of both of these lines. So if we think about slope, you've probably been asked or have experienced the word equation for slope before, where we say that slope is always the rise over the run. And in this case, if we look at this graph, our rise is actually our mass, which has been measured in grams. And our run is our volume, which has been measured in milliliters. And this is significant for us because it gives us a little bit more information about what our slope is. When we take our mass and divide by our volume, we're figuring out how much mass is in any given area of volume. And that is a key idea because that is our density. So what we see when we kind of write all this out, and this is the big takeaway from our lab, is that the slope of the line is going to equal the density of our object. So once you are done with your data, the thing that I asked you to write down or to keep track of was the slope of A and the slope of B. So if you have not written those down in your lab packet, I need you to open back up that assignment so that you can find those trend lines, and then make sure you've clicked the label so that it labels with the use equation, I think is how Google Sheets words it. And that should give you the equation for each of your lines. And you can pull the slope from those equations. And then once you have the slope of line A and line B, you're ready to move on to the lab reflection, because we can actually identify what metal A was and what metal B was based on those densities. So hopefully your densities line up pretty close to some of the densities in that table, and you all can make an educated guess. As a reminder, metal A was our silvery metal, and metal B was our goldish metal. Thanks for watching. Hopefully this clears up some of the end of lab stuff that we didn't have time to get to last class. And go ahead and finish up the lab reflection and those final conclusion questions, because this information here should be everything you need. Thank you.